Welcome to Lesson A, which is about functions. Let's remember what a function is. A function is a rule that takes x as an input, and the rule does something with that number and comes out with another number called y, often written as f of x. The x is the input variable, the y is the output variable. The values of x are called the domain, and the values of y are called the range. Often, instead of saying input, we call it the independent variable, and instead of the output, sometimes it's known as the dependent variable. The reason why is the value of y depends on what the x value is. All right, go ahead and copy down these words and hit pause. So here's the thing about this. For every x that we put into the function, there can only be one predictable output y. If I put in a number into my function, I need to get the same number in the output every single time. The expression y equals f of x means y is a function of x. That's what the little parentheses are. So whenever you see these parentheses, you can say of. Another way of saying it is y depends on the value of x, right? Remember that y is the dependent variable, and it depends on what x is. All right, warning. We don't always use y and x. Sometimes we use other letters to represent the functions. For instance, volume depends on the radius of a sphere, okay? Maybe the position in the air depends on time, or the area of a certain rectangle depends on the width, right? There are many ways to name functions, and when you read these, you would say v of r, y of t, a of w, or more importantly, you could also say v is a function that depends on r, y is a function that depends on t, and a is a function that depends on width. A lot of you like to play soccer, so that's going to be our first example. A soccer ball is launched from the ground. The height of the ball, h in meters, depends on the time after the launch, t in seconds. The formula h of t equals 15t minus 5t squared calculates this scenario. Let's make sure we're clear. It said here that the height of the ball in meters depends. Well, since the height of the ball is that which depends, we're going to be plotting the height on the y-axis. It's the output of the function. And what it depends on is the launch t in seconds, right? Which is the time. And time is going to be plotted on the x-axis. It's the independent variable. And this equation helps us calculate the height at any given time. All right, question 1. Interpret the meaning of the following mathematical expression using units. H of 1.5 equals 11.25. Well, I look here. I must remember that the variable that's inside the parentheses, that's the independent variable, right? And therefore, h of 1.5, that's telling me that the time is 1.5, and what are the units? It says seconds. So the time is 1.5 seconds. This number is equal to h of 1.5. This right here is the height. And I assume that it would be in meters. 11.25 meters. Well, they told me that it was in meters. So what does that mean? It means that the ball is located at 11.25 meters in the air at the moment 1.5 seconds. Okay, that's how high the ball is at this time. The important takeaway here is the number that's inside the parentheses is that number. When I see the 1.5 in the parentheses, I look at my formula and I say, oh, whatever number is in that parentheses, that's the t. That's the time. Question number 2. Calculate h of 2 and interpret the meaning of the answer using units. So it's telling me to calculate the h, so I'm calculating the height. What does the 2 mean? Well, I got to remember that it's h of t. Therefore, time is 2. Time is equal to 2. So what that means is I'm going to be plugging in the number 2 everywhere that I see t. So h of 2 equals 15 times 2 minus 5 times 2 squared. Sometimes people put parentheses to show the multiplication here. Well, at this point, I have an expression that I need to calculate. Using PEMDAS, it helps me figure out what order of operations I must do. Well, there are no parentheses for me to do in this example. There is an exponent, though. I have the 2 squared, so that's the first thing I'm going to do. So I have 15 times 2. I didn't do that yet. 5 times 2 squared, which is 4. So as you can see here, I just did the exponent. I do that first. The next thing I need to do are all of the multiplications in the problem. h of 2 equals 15 times 2, which is 30. And then I have a minus sign there. And I need to do 5 times 4, which is 20. So I just did all of the multiplications. There are no divisions. There are no additions. The very last thing I do is subtract those numbers, and that gives me 10. Okay? So let me write my answer over here. I have h of 2, and my answer was 10. So what does that mean? Well, I got to remember that the number inside the parentheses is my time, and that's in seconds. And that number is the result of the function, which gives me the height. So therefore, the interpretation is at 2 seconds, the ball is 10, is it feet or meters? It is meters. 10 meters in the air. That would be how I would interpret this using a complete sentence. The other thing I can do is I can type the function in Desmos exactly as the formula gave it to me. And I can literally say h of 2. And by doing that, it gives me the result of 10. It also graphed it right here. And as you can see that at time 2, the thing about Desmos is that when it sees t, it already knows to interpret that as x, because often we use a lot of graphs that use time as our x-axis, and Desmos knows that. So at time equals 2, I can see that my ball is located 10 meters in the air. Another thing I can do is say, hey, what happens when x equals 2? It creates a different line here, and where it intersects, it gives me the point. It says, hey, at 2 seconds, it's located 10 feet in the air. All right, let's do the next question. Solve for h of t equals 9 and interpret the meaning of the answer using units. Now be very careful. Notice that they didn't put a number in the parentheses. The number is on the other side of the equal sign. So here, I don't know the time. The time is the question. I don't know what time. I do know that my ball is located at 9 meters. So to do that, I'm going to go look at my graph in Desmos and see when my ball is 9 meters high. Okay, so one thing I can do to do that is say, hey, when is my y value equal to 9? And there are 2 times when that happens. It happens at this time, and it also happens at that time. So how do I write down my answers? We must round to 3 decimal places in AP Precalculus. When I write my answers, I have to make sure there are 3 numbers after the decimal place, especially if they're not 0. And I'm going to box in my final answer. Why is it that I have 2 answers? Well, let's remember what's happening here. Remember, this is a soccer ball that goes up and then back down again. It's going to be at the same height twice, once when it's going up and once when it's going down. So sometimes when we solve for functions, when we're solving for time or solving for x, we can have multiple answers. However, when I'm being asked to solve for the height, I can only get one answer because of the rule of a function. The rule of the function is, for each input value of x, there can only be one predictable output y. which brings us to our final example. We have two graphs here. One of them is a function, and one of them is not a function. And we must remember what that means. A function means that for every x, there can only be one y value. So for instance, this function over here at x equals negative 10, I'm noticing I have a graph here at negative 10, and I also have a graph here at 20. That means x equals negative 10 points to two y values, y equals 20 and y equals negative 10. That's a problem. So this is not a function. So how would I justify that in complete sentences? I would say this is not a function, comma, because there are x values, such as negative 10, that are tied to two y values. And it happens a lot. Now, I want to be very clear that in algebra class, your algebra teacher was lazy and said, hey, does it pass the vertical line test? That means basically you draw a vertical line everywhere where you can, and if there's even a single spot where it hits the line twice, a vertical line, then it's not a function, right? So this one fails a lot. This failed the vertical line test here. This failed the vertical line test here. There's only one point right here at 15 where it passes the vertical line test. So in algebra class, to say that this is not a function, all you had to say was it failed the vertical line test. However, they don't want you to say that on the AP Pre-Cal exam. They want you to say that there are x values tied to two y values. On this one over here, this graph is a function, not because it passes the vertical line test everywhere, but because for every x value, there is only one y value. And that's happening everywhere. And that's why this is a function.